Okay, so I want to start off by recalling the general format of a Bernoulli equation, and we have it right here. So notice that the general format of a Bernoulli equation is that of a first order non-linear differential equation. And so why is it nonlinear? It's nonlinear because of this y to the n term, right? So this is what stops the Bernoulli equation from being linear. And remember, with this setup, we're assuming that n is not equal to 0 and n is not equal to 1. Okay? Because if n is equal to 0 or 1, then we already have a method for solving the differential equation. Okay. Now, so this is the general format. And down here we have the substitution. So this is the substitution that we apply. We apply the substitution that v is equal to y to the power of 1 minus n. That's the same, or it's equivalent to saying that y is equal to v to the 1 over 1 minus n. And once we apply this substitution, we transform our Bernoulli equation, right, from this nonlinear first order equation into this equation. This now is linear, right? So we've got a linear first order equation. This version might look a little different from the equation that we wrote on the board. The only difference is, let me actually just go ahead and show you. So I think on the board today, we had 1 over n minus 1 v prime plus p of x v equals f of x. And so all I did was just multiply both sides by n minus 1.
It's 2015.
Right, and so when I multiply both sides by n minus 1, that cancels out that factor of 1 over n minus 1. And now that n minus 1 is going to be multiplied by p v, and it's also going to be multiplied by f of x. Okay, so then just to recap, our old equation is y prime plus py equals fy to the n. Our old unknown is y, right? We're trying to solve for y. We apply our transformation, and our new equation becomes v prime plus 1 minus n v prime plus 1 minus n p v equals 1 minus n f. Okay, and our new unknown is going to be v. So this new equation, the new equation is a linear first order equation. We know how to solve it. We will solve it for v and then back substitute to figure out our old unknown, which is y. Okay, and how will we back substitute? We'll use the substitution that we used to transform the Bernoulli equation to a linear first order. Okay, so for today's video, what I want to do is I want to go through actually 3 different examples. This first example here is kind of straightforward. We want to solve the Bernoulli equation, and then here's our equation. Maybe the first thing to point out is we've got y and t. So our independent variable is t instead of being x. The first thing I want to do is I want to rewrite this equation so that it looks more like our general format for a Bernoulli equation. Okay, so how am I going to rewrite this? I'm just going to rewrite it. First, I'm going to add y cubed to both sides. So I have y cubed equals, now let's see here, so it'll be t squared y prime plus 2ty equals y cubed. Now I'm going to divide both sides by t squared, so I have y prime plus 2 over ty equals 1 over t squared y cubed. So at this stage, it should be easy to tell, easy to figure out my p. Let me zoom in here. Right, so the general format has a p and it has an f, right? I need to know p and I need to know f in order to get my new equation, right? And I need to know P, F, and N. So let's go ahead and looking at this, P is going to be this 2 over T, F is going to be 1 over T squared, and N is going to be 3. So in fact, I can write that down. P, so instead of P of X is P of T, is 2 over T. F of T is 1 over T squared, and N is equal to 3. Okay. So I actually think it's very helpful to, when we're first starting these examples, to kind of keep this format so we can keep track of what it is we're doing. So let's see, what we're going to fill out this chart here. Okay, so what is our old equation? Our old equation is, we can copy it from here. Oh. Our old equation was the same thing. We can copy it from here. Copy. Paste. So that's our old equation. Our old unknown is y. Our new equation, let's figure out our new equation, because this is what we need. Copy. So I'm going to use that formula over here. Paste. Okay, it's got a lot of crap. I can just erase that. So this is going to be my new equation. I just literally need to look at this and, replace, so remember up here we said n is equal to 3. So I can go ahead and put that in. So I'll have v prime plus 1 minus 3, p of x, v, equals 1 minus 3, f of x, right? Because n is equal to 3. And then I can replace p of t with 2 over t. So this is going to be, we can put 2 over x. Okay. V, and then we've got the 1 minus 3. And we have v prime, 1 minus 3. Now what about the f? So 1 over t squared. So let's make this 1 over x squared, right? So if f of t is 1 over t squared, f of x is 1 over x squared. Okay, now I'm going to just simplify. So 1 minus 3 is negative 2 times 2 over x times v. And then negative 2 times 1 over x squared. So we should get v prime minus 4 over x v equals negative 2 over x squared. So this is my new equation, right? V prime minus 4 over x v equals negative 2 over x squared. So notice that my new equation is linear, first order, so I know exactly how I'm going to solve it. My new unknown is v, so I'm going to solve for v. Okay, so now we need to recall the 3 steps for solving, linear first order differential equation. So step 1 is to get a solution to your complementary equation. And then step 2 is to get u, and then step 3 is to multiply them together, right? Multiply them together, right? So I think before we were using y1 for the solution to our complementary equation, and then u is a solution. Remember, we use the equation u prime is equal to q over y1, and q is the part that's on the right-hand side of the equation, and then we multiply them together, so we say our solution is u times y1. notice that this y1 and this y is not the same as the y that we're solving for, because really we're trying to solve this equation. We're really trying to solve this equation here, v prime minus 4 over xv equals negative 2 over x squared. Okay, so let's do step 1, which is going to involve the complementary, finding a solution of the complementary equation. So our complementary equation is v prime minus 4 over x v equals 0. So this is actually separable. Okay, so the result of for step 1, the complementary equation is always a separable equation, so I'm going to rewrite it. So let's see here. So v prime equals 4 over x v. Okay, and now dv, oh, actually, let me divide both sides by v. So v prime over v equals 4 over x, right? So I'm dividing both sides. And now I'm going to write it in differential form. Maybe I need to widen my window here. So I'll have dv over v is equal to 4 over x dx. And I integrate both sides. So I'm going to get the natural log of v, for absolute value of v, is equal to 4 times the natural log of x plus a constant. I'm going to solve this, and I get the natural log of v is equal to a constant times e to the 4 natural log x. But I can rewrite e to the 4 natural log x as e to the natural log of x to the 4th power using my log rules, right? So a times log, or natural log of b, is equal to the natural log of b to the a. Right? So I just took that 4 and moved it upstairs on the x, right? Okay. And then the e and the natural log are inverse operations of each other, right? So they cancel each other out, and I'm just left with c, a constant times x to the 4th power. So I can just choose c equal to 1. So since I just need any solution of the complementary equation, I can just choose c equal to 1. And my, in this case, v1 is going to just be equal to x to the 4th. So the conclusion of step 1 is v1 is equal to x to the 4th. Okay. Now, for step 2, remember, is to get that u, is to solve for u. Right? So step 2 is to get u, and we have this formula here. Oh, sorry. We have that formula, u prime is q over y1. In this case, our equation is v prime minus 4 over xv equals negative 2 over x squared. So my q is going to be this right-hand side, negative 2 over x squared. Okay, so let me go ahead and erase. And so we'll say step 2. So u prime is equal to, now it's going to be a fraction. The numerator of the fraction is this right-hand side, negative 2 over x squared. The denominator is the result of step 1, so that's over x to the 4th. So let me try to simplify this. I'll have negative 2 over x to the 6th power. That's the same thing as negative 2x to the power of negative 6. Now it's really going to be really easy for me to figure out if u prime is equal to negative 2x to the negative 6, then this is a separable equation. So I can rewrite it, du is negative 2x to the negative 6 dx. Integrate both sides. On the left-hand side, I get u. And on the right-hand side, I'll get negative 2 x to the negative 5 over negative 5. So what did I use? I used some basic integration rules, right, to figure this out. So make sure that you are practicing and beefing up on your integration skills, right? Because you don't want to get tripped up over integrating a rational function. Okay, so we're going to have u is equal to the negative 2 and negative 5. The negatives cancel out, so I'll have 2/5 x to the negative 5 plus a constant. So I'll use that as my result of step 2. U equals 2/5 x to the negative 5 plus c. And then step 3 is to multiply step 1 and the result of step 1 and step 2 together, and that'll give you the solution, the answer. So for us, step 3 is going to be v equals v1 times u. Oh, let me put it here. V equals v1 times u. And v1 is x to the 4th. U is 2/5 x to the negative 5 plus a constant. 2/5 x to the negative 5 plus a constant. So we can simplify this to be 2/5 x to the negative 1 plus c x to the 4th power. Okie dokie. So for step 3, v equals
it's 2030
x to the negative 1 plus c x to the 4th power. And this is the solution for our differential equation. Are we done? We're not done with our entire problem though, because our problem was to solve an equation which is given in terms of y, right? Our unknown is y, right? Y prime, y cubed. So our answer should not be v equals 2/5 x. Our answer needs to be in terms of y and t. So we need to give a formula for y in terms of t. How do we do that? We need to go back to our substitution. So the substitution that we used was v equals y to the 1 minus n. So in this, we said that's the same thing as y equals v to the 1 over 1 minus n. So for us, because n is equal to 3, y is equal to v to the 1 over 1 minus 3, which is v to the negative 1/2. Okay? And then over here, that's the same thing as v equals y to the 1 minus 3, v equals y to the negative 2. So now let's go down here to our answer. V equals y to the negative 2. So v equals y to the negative 2. But v is also equal to 2/5. And we can switch our variable here to t to the negative 1 plus c times t to the 4th power. Right? So this is the same thing as 1 over y squared is 2/5 t to the negative 1 plus c t to the 4th power. If we want to solve for y, cross multiply. So y squared times 2/5 t to the negative 1 plus c t to the 4th power is equal to 1. Multiply both sides by y. Now divide both sides by this stuff involving t. So we get 1 over 2/5 t to the negative 1 plus c t to the 4th equals y squared. And so the last thing we would do is take the square root of both sides, right? So that actually looks a little bit sloppy. So I would just say raise both sides to the 1/2. 1/2, and the 2 will cancel out, and we'll get y equals 1 over 2/5 t to the negative 1 plus c t to the 4th power to the 1/2. Alrighty, so that is the solution for our first example here. Let's move to a second example. Solve the Bernoulli equation. Now notice here we have, we've got a Bernoulli equation, and we have two constants. So one constant is epsilon, and the other constant is sigma. Now, epsilon is a number, usually a small number, right? Epsilon is a small number, and sigma is another number, and they're both positive. A differential equation like this would be used in the study of stability of fluid flow. So, for instance, imagine you've got some object, that's sticking in the water, and you're looking to see how does fluid flow around that object, right? So if fluid is coming here, it can't just brush through the object. It's going to have to be diverted to move around the object, and now sometimes it's going to move here, right? So the question is, how does fluid flow, right? How does fluid flow? It's a crappy picture, but you can kind of get an idea. And so what you would do is you would let epsilon go to 0. So you would look at a solution like this, and then you would look at the family of solutions and let your parameter epsilon tend to 0, or see what happens when you change sigma, right? Maybe sigma keeps track of the viscosity of the fluid, because the thicker a fluid is, or the stickier it is, the slower it's going to move, right? So this is a Bernoulli equation. Notice it is nonlinear, first order, and from here, because it is because of the way it's written, if we've got y prime equals epsilon y minus sigma y cubed, we can already tell straight off the bat that n is equal to 3. Well, let's see here. First, let me rewrite it. Y prime minus epsilon y equals negative sigma y cubed. So n is going to be equal to 3. Now, what is my p of x? And what is my f of x? P of x is going to be a constant function, negative epsilon. F of x is going to be a constant function, negative sigma. Okie dokie. So, let's see here. Copy. Let's use our same little rubric here to write down old equation, new equation, so we can keep track of what we're doing. So our old equation, just from the looks of it, is y prime minus epsilon y equals negative sigma y cubed. And the old unknown is y. What is our new equation? In order to figure out our new equation, we need to look back at this right here. This formula tells us what our new equation is. Copy. Paste. Okay. Now I just need to fill this in according to our values for N, P, and F. Okay. So N we said is equal to 3, so that's going to be, N is equal to 3, so we'll have 1 minus 3. So V prime plus 1 minus 3 times P is equal to negative epsilon. So we just negative epsilon V equals 1 minus 3. And F is negative sigma times negative sigma. So I have V prime plus 2 epsilon V equals 2 sigma. Okay. So that's our new equation. V prime plus 2 epsilon V equals 2 sigma. And we're going to solve this for our new unknown, which is v. So to solve the equation, right, to solve this new equation, we're going to do our 3 steps again, right? So step 1 is going to be to find a solution to our complementary equation. What is our complementary equation? V prime plus 2 epsilon v equals 0. So we'll have v prime plus 2 epsilon v equals 0. Okay? So then for here I'll have v prime equals negative 2 epsilon v. V prime over v equals negative 2 epsilon. So dv over v equals negative 2 epsilon dx. We can use x or t because no independent variable is mentioned in the equation. Then we integrate both sides. And on the left-hand side, we'll have the natural log of the absolute value of v. And on the right-hand side, we'll have negative 2 epsilon x plus a constant. We'll exponentiate both sides, and we'll get the absolute value of e is equal to a constant times e to the negative 2 epsilon x. And this is the same as writing v equals a constant times e to the negative 2 epsilon x. Okay. We just need a solution to the complementary equation, so we can take c equal to 1 and say that v1 is e to the negative 2 epsilon x. So v1 equals e to the negative 2 epsilon x. Now we need to do step 2. Step 2, as we recall, is finding u. So u, in order to find u, we integrated u prime. Okay, so we have u prime equals, now in the denominator is going to be our v1, which is e to the negative 2 epsilon x. And in the numerator, we'll have this forcing term here, 2 sigma. So the numerator will have 2 sigma. And we can rewrite this in integral term. So now we'll know, we can actually simplify this. What is 2 sigma divided by e to the negative 2 epsilon x? That's going to be 2 sigma e to the 2 epsilon x. So 2 sigma e to the 2 epsilon x dx. Integrate, integrate. On the left-hand side, we'll have u. And on the right-hand side, well, now we can bring out the 2 sigma. What's the integral of e to the 2 epsilon x dx? Do a u substitution. So if you do a u substitution, let u equal 2 epsilon x. This is poor notation because that u looks like that u, but it's not supposed to be. So we can just use another notation. Do a w substitution. Let w equal 2 epsilon x, then dw is 2 epsilon dx, right? So dx is 1 over 2 epsilon times dw. Okay, so 1 over 2 epsilon times dw. The 2 sigma we can bring down. We've got the integral of e to the w. And we know the integral of e to the w is just e to the w plus a constant. The 2's will cancel out and we'll have sigma over epsilon. So sigma over epsilon times e to the w plus c. But what was w? 2 epsilon x. We have sigma over epsilon e to the 2 epsilon x plus a constant. So w is 2 epsilon x. So when we back substitute, we have sigma over epsilon times e to the 2 epsilon x plus a constant. So that's our u. Sigma over epsilon e to the 2 epsilon x plus a constant. So now for step 3, we just multiply the results of step 1 and step 2, right? So we'll just get our solution that v is equal to e to the negative 2 epsilon x times sigma over epsilon e to the 2 epsilon x plus a constant, which is the same as v equals sigma over epsilon plus c e to the negative 2 epsilon x. Now we're not done because we need to back substitute to get an answer in terms of y. So now since n, so what was our substitution? That's the key. Since n equals 3, the substitution we used was v equals y to the 1 minus n, which in this case is v equals y to the 1 minus 3, which is v equals y to the negative 2. So let's go down here and substitute v is equal to y to the negative 2. So 1 over y squared is equal to sigma over epsilon plus a constant times e to the negative 2 epsilon x. So that means y squared is equal to the reciprocal of the right-hand side. So 1 over sigma over epsilon plus c e to the 2 epsilon x. And then we take the square root of both sides. So we have 1 over the square root of sigma over epsilon plus c e to the 2 epsilon x.
It's 2045.
Okay. And now the last problem here is to solve the IVP. And here's what I want to do to solve the IVP. Essentially, there's nothing special about this being an initial value problem. Here's what's special. Look at this coefficient of y. So the key is that in this case, our p of x is just a constant negative 2. F of x is just a constant 2, but n is equal to 1/2. So our substitution is going to be v equals y to the 1 minus n, which is y to the 1 minus 1/2, which is y to the 1/2. Okay. Our new equation is going to be v prime plus 1 minus n p of x v equals 1 minus n f of x. N is equal to 1/2. So it'll be v prime plus 1 minus 1/2. P is equal to negative 2. Negative 2v equals, n is 1/2, so it'll be 1 minus 1/2. Then what's the f? The f is 2. So we'll have v prime plus 1/2 times negative 2v equals 1/2 times 2. So I have 1 minus v. V prime minus v equals 1. That's not this one. Is it close to this one? Nope. Not close to that one. All right. So I'm just going to outline the procedure for this. So this is our new equation. It's linear. Step 1. Now I want you to try this at home. Step 1 would give you, for instance, v1 equals e to the x. Step 2, let's see here. So for step 2, we need to solve u prime equals 1 over e to the x, which is e to the negative x. And if u prime is equal to negative x, u is equal to negative e to the negative x plus constant. So again, I'm doing this kind of fast, but I want you to make sure that you are understanding each step and you're supposed to be doing it yourself and then verifying that we get the same answer. Notice I just rearranged this and put the c in front. So it's c minus e to the negative x. And now step 3, put them together. V is equal to c minus e to the negative x times e to the x So we'll just get c e to the x minus 1 is equal to v. And then we say we're not done yet because really v was equal to y to the 1/2, right? So if v is equal to y to the 1/2, that means y to the 1/2 is equal to c e to the x minus 1, right? So we can square both sides to get y by itself, and y equals c e to the x minus 1 quantity squared. And now, because it's an initial value problem, we say, well, y of 0 is equal to 1, so this is going to help us to figure out c. So when x is equal to 0, y is equal to 1. So 1 is equal to c times e to the 0 minus 1, quantity squared. So 1 is equal to c minus 1 squared. So we could take plus or minus 1 equal to c minus 1. So c is equal to 1 plus or minus 1. So that means we could choose c to be equal to 2 or 0. C equals 2. We can go with that. So then c is equal to 2. Then what's our solution here? If c equals 2, then this equation here turns into y equals 2 e to the x minus 1 quantity squared. If we use c equals 0, then we just get the constant solution y equals 1, which is a trivial solution. Okay, thank you.